Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, today we will take few numericals on Snell's law. So let us start with the numericals on Snell's law. We'll take a few good examples on this particular concept. Okay, let's start. Hello students, today we'll take few numericals on Snell's law. Numericals on Snell's law. We know that Snell's law can be applied to a prism when ray undergoes refraction. In the case of a prism, we have seen that when ray undergoes minimum deviation, then it undergoes refraction at two faces of the prism. First face is where the ray strikes, and the second one when the ray comes out of the prism. So in these two cases, these two phases, we can apply Snell's law. So whenever there is a refraction taking place, we can always apply Snell's law. So now the question is, we have a question, say number, I'll start with question number 5. The question is, I'll write the question for you. To the angle of incidence of a ray of light the angle of incidence for a ray of light at a refracting surface of a prism is 45 degree. That means to the first face it is hitting at an angle of 45 degree, and it says that the angle of the prism is 60 degree. Next it says if the ray undergoes minimum deviation, then we have to find the refractive index of the prism material. Okay, if the angle of minimum deviation, refractive index of the prism material. So you have to find, then we have to find so the ray is also undergoing angle of minimum deviation, and you have to find that angle of minimum deviation. And the refractive index of the prism. So the question is very simple. We have a prism whose angle of prism is 60 degree. The angle of incidence is, so now we have a prism. We have a prism. So this is a prism. This is the solution to this question. Let us say ABC is a prism, where A is the angle of prism, which is given as 60 degree. The ray undergoes minimum deviation. If the ray undergoes minimum deviation, then the ray has to be parallel to the base. This is how the ray moves inside the prism. Inside the prism, the ray has to be parallel. Whenever there is minimum deviation, then the ray inside the prism has to be parallel to the base of the prism. So therefore, this line, this ray is parallel to this base. Now in this situation, we have normal. We can draw a normal. So this is a normal, and at this point, this is the normal. We have drawn two normals at 2 points, and this is given as 60 and this is given as 45 degree. It's given in the question that the angle of incidence is 45. For we know that for minimum deviation, when ray suffers minimum deviation, in that case the angle of incidence I equals to the angle of emergence, that is E, which is obviously 45 degree. So in both the cases the I and E are 45, this is 60, and in this situation we have a relation that R1 becomes equal to R2, and we have a formula that A equals to R1 plus R2. This is one equation that is used in the prism. So because R1 and R2 are same, this is your R1 and this is R2. Both are same. So I will call this is 2R, R plus R, 2R is A. So from here R is A by 2. A is given as 60 by 2. So obviously it is 30 degree. So this angle is 30 degree, this angle is also 30 degree. Now because this is parallel, this angle is 60 and this angle will be obviously 60, because this angle is 30 and therefore the total angle should be 90, so this should be 60 and this should also be 60. So this is 60, this is 60, this is 30. Now you have to find the angle of minimum deviation and the refractive index of the prism material. So for that we know that A plus delta equals to I plus E. So from here, when delta is minimum, delta M equals to I plus E minus A. But in this situation, I and E are same. I will just substitute the values to get the value of delta M. If I put I equals to 60, I is 45, E is also 45, A is 60. So from here it is 90 minus 60, so it is 30 degree. So the angle of minimum deviation can be, you can see here, this angle. This angle is delta M in this situation, and that comes out to be 30 degree. Okay, so in the angle of minimum deviation is 30 degree, and this is the answer for angle of minimum deviation. Next part of the question is to find the refractive index of the prism material. To find this, we'll use the formula of Snell's law, that mu is sine of I divided by sine of R at any phase, and we also know that this is sine A plus delta M by 2 divided by sine A by 2. This is the prism formula. So substituting these values, you will have, now I substitute the value, mu comes out to be sine of A is 60 plus delta M is 30, A plus dm divided by 2 divided by sine of A by 2, that is 60 by 2. So in this situation we have sine of 90 divided by 2, 45, divided by sine of 30, and that comes out to be sine 45 is 1 upon root 2. Okay, and sine 30 is half, so it is 1 by 2, 2 goes up, 2 goes up. So finally this comes out to be root 2. This cancels and gives you root 2. So refractive index of the prism comes out to be root 2. So finally we have got two answers, that the refractive index comes out to be root 2. Second part. First part, the deviation angle, that comes out to be 30 degree. So these are the answer to this question. Another way is that we can also solve by directly putting, as I told you, we don't have to go for this lengthy calculations. We can directly go for sine I and R. If I use this one, then I will have sine of 45, because I is 45, you can see here I is 45 and R is both are same, so this comes out to 30. As we know, this comes out to 30, R comes out to 30 here. So I can put sine 30 45 by sine 30, directly we can get. The previous case also we got the same thing, that sine 45 by sine 30, sine 45 sine 30. So anyway, you will get the answer. So these are the two answers. Okay, thank you.